So I'm going to look at this question here, which tells you that a particular variety of wheat have got a recessive mutant gene. So the first thing I now know is because it's recessive, it means that I need two alleles to show the trait. Now it goes on to tell me in the question that they are homozygous, and that homozygous state is going to cause an absence of chlorophyll. Now I know that chlorophyll, I'm going to write a little note here, is my green pigment. That green pigment which allows for photosynthesis to occur. So I'm being told that the mutant allele is recessive. It's going to give me this absence of chlorophyll. Now it therefore goes on and tells me a few bits more information in the question. So seeds from self-pollinated heterozygous plants were germinated. Now these are heterozygous, and they've already told me that the absence, the recessive trait, is going to give me an absence of chlorophyll. So therefore I can make the assumption that because I've got a green plant, that green plant is therefore going to be heterozygous, capital G, small g, and I have another green plant and it is going to be capital G, small g, because it is heterozygous. Now I'm then told that they yield 18 white plants and 49 normal. So if I think about how would this genetic cross look, I know that the gametes will either have a capital G or a small g, capital G or a small g. So meiosis is going to produce my gametes, and my gametes are therefore going to give me the potential offspring. So if I now bring this into a Punnett diagram, I quickly draw that across. What I can see is if it follows Mendel's law of independent assortment, then what I will get is, as they've rightly stated, a ratio of 3 green to 1 white. Now this is a phenotypic ratio, and it's important to note because my genotypic ratio would be slightly different. So my phenotype would be green to white, and you can clearly see that I have got 1 white and 3 green. However, if I'm looking at the possible genotypes, I have a capital G, or capital G, small g. So it depends if it's homozygous dominant or whether it is heterozygous, and whether it is homozygous recessive. So there is my phenotypic ratio, 3 to 1 if we follow Mendel's law of independent assortment. So let's just have a look then and see what they are going to ask us to do. Well, they're asking us to actually carry out a chi-squared test. So they want to see whether or not our observed frequency, i.e. our 18 white and 49 plants, which are green, actually follow that law of Mendel's independent assortment. So let's look at this then. Chi-squared is where we're going to look at the observed frequency and we're going to minus our expected frequency. So what we need to do is we need to actually bring in how many did we observe. So there was green and there was white, and we observed 49 green and 18 white. So that's our observed, and we want to work out what our expected frequency is. So to work out our expected frequency, what we need to do then is we need to add these two together. So 49 plus 18 will give us a total of 67. So there is a total plants, 67 of them. We need to know, well, 3 plus 1 is 4. So if we take that 67 and we divide it by 4, that will give us 16.75. So our expected ratio for white, which was a 1, is 16.75. And then what we do is we do 16.75 times 3, and that will give us our ratio for the green plants, which is 50.75. 0.25. So now we have our expected ratio. We know what we observed because it was given to us in the question. So what they now want us to do is to substitute that in. So therefore, if I know my observed, for example, is 49 minus 50.25 squared divided by 50.25 plus my 18 minus 16.75 squared divided by my 16.75, that will therefore give me an answer which is 0.124. So I now have my chi-squared value, which is calculated at 0.124. And all I've done is I've substituted in the numbers to the equation. Now it's asking me how many degrees of freedom are there? Well, whenever you're looking at this, it's always n minus 1. So therefore, in this case, we had 2, green and white, minus 1. So therefore, my degrees of freedom is 1. So what else could they ask me? Well, the next thing they could ask me is they could say to me, okay, if you've now calculated your chi-squared value, so let's just remind ourselves, our chi-squared value is 0.124, and they're telling us that the critical value at these degrees of freedom and at a 0.05 probability is 3.84. Well, the first thing we need to note is that our chi-squared value that we actually measured was 0.124. So this is less than the critical value, which is 3.84. So straight away, I would be writing this down as my answer. So straight away, I know that my chi-squared value is less than the 3.84. Now, it's important to note, if my number is less than the critical value, that tells me that I normally accept my null hypothesis. And therefore, if I'm accepting my null hypothesis, I'm saying that there is no significance between the differences. Now, it's important whenever you're reading these questions that you take your time to read what's actually been stated. So they're asking you to either accept or reject the hypothesis. Well, if I go solely on accepting my null hypothesis, I will say I'll accept my null hypothesis, but this is where you need to be careful. Go back and reread the question. The chi-squared test to see if the results support the hypothesis that the deviation of these results from the Mendelian ratio is significant. Well, I am not saying it's significant. My calculated chi-squared value is less than the critical value. So that would be an accepting of a null hypothesis that there is no significant difference. So the fact that they have said in their hypothesis that there is a significance means that my answer has to be very specific, that I am rejecting the hypothesis because my chi-squared value of 0.124 is less than the critical value of 3.84, which indicates there is no significant difference. So it is very important when you're answering a question like this that you always look at, first of all, what do you already know, but then don't get caught out by not referring back to the question, because you could have written that you accept a null hypothesis, there's no significant difference, but you haven't actually answered the question in front of you. So you could lose a marking point.